All right. Um, uh, First hurdle, the technical hurdle, somewhat smoothly done. So what I wanted to start with is a little story. A few years ago, a husband and wife both applied for a new credit card, and they lived together, they have had been together for 20 years, they had shared bank accounts, they basically had very similar backgrounds, and they put their details in when applying for their credit cards and um, went through the entire process. And at the end of the process, they compared their credit limits, and to their surprise, they saw a massive difference. The husband's credit limit was much larger than the wife's. So they said we must have put something in wrong there. Something happened. We did something wrong. Let's try this again. Let's start over. So they went through the process again. They put in their birth dates, they put in where they live, they put in their finances, all of the information that they shared, and that is was so similar because they had been together for such a long time. And when they compared their credit limits again, the credit limits were vastly different. So they said at this point, we did this very thoroughly. We paid a lot of attention. Something's going on. So they said, well, you know what? Let's try this again. Let's go through this entire application process and let's just change a few variables. So they started and they changed their income, and they compared what kind of credit limits they ended up with. And the difference was much smaller because they had basically aligned everything, and they went through education, they went through the different addresses, they just changed different kinds of aspects of their application, and over again the credit limits were pretty similar. And that was until they changed the following: they put in the same salary, they put in the same education, the same kind of savings, the same address, the same spending behavior, but they changed their gender, male and female. And when they looked at their credit limits, they realized there was that gap that they had been experiencing. All of a sudden, that gap was much bigger. That was a good number of years ago, and what followed this was a lot of, well, A, apologies from the bank, but B, a lot of soul searching among data scientists and data professionals who had up to that point regarded data and algorithms and any automated process as being unbiased and as being so much better at decision making than a human. And all of a sudden, they realized it was not. So that is just one of lots of examples, and a lot of the bias that we can find in algorithms and machines that make decisions for us isn't actually just gender based, but it can be racial as well. So from 2019, a headline of millions of Black people affected by racial bias in healthcare algorithms. And that is a really important topic. And if you realize that certain allocations of certain medication or treatment may be biased based on something that you cannot impact and that it shouldn't be biased by, that can be really scary. If you think about COVID vaccines, for example, more recently, and how priorities were allocated or would have been allocated for vaccination, an algorithm would have done that. It wasn't someone in an office sitting somewhere and going through every UK adult's medical history and their background and their gender and age and so on. It was an algorithm, it was automated. But as we can see in this headline, there can be bias in those kind of algorithms. A few years ago, Amazon tried to use AI, or artificial intelligence, and algorithms to create a recruiting tool that would help them recruit the right people and do so more efficiently, and what they originally thought in a more unbiased manner. But actually, even the big guys, even the Amazons of this world, don't always get it right. And what they realized is the algorithm they created was actually favoring men for technical jobs. And then lastly, Facebook has, of course, been in the news quite a bit recently when it comes to algorithms. And one thing that this was a few years ago, but for Facebook specifically, they found that there was an ad serving algorithm that discriminated by gender and race. And I'm not just talking about ads like girls were shown an ad for a product like a Barbie and boys were shown like a car or something like that. But ads can also be job ads, and we'll talk about that in a moment. But if the algorithm or the platforms that we use for recruitment are biased in who they show your ad or your job ad to, then that can be a real driver of a biased group of applicants applying for certain jobs. So as an example, if you are using Facebook or any kind of social media to recruit for warehouse staff and you upload your ad and tick the industry that it's in, could be manual labor, or you may tick wholesale, or you may tick something like that, and then Facebook's or the social media platform's algorithm thinks, oh great, that's the category that we should be showing to men, isn't it? Then they do that, and as a result you will receive a lot more applications from men, but not because women aren't skilled at it or don't want to do it. It's simply because they didn't see the ad. So those kind of algorithms and decision making tools can really affect who actually makes it to your door, when it comes to CVs and recruitment. So that all sounds a bit scary, doesn't it? You know, it sounds like there is something out there, a big algorithm monster out somewhere in the universe that's biased and it doesn't like women, or it's racially discriminatory. But actually, algorithms at the end of the day are just a set of instructions that help us make decisions or execute processes. And the key word there is instructions. If there's an instruction, it has to be given by someone. An instruction is something that's being executed. An algorithm isn't something that's out there that's just created out of nothing and all of a sudden it's there and it makes decisions and it's discriminating left, right, and center. An algorithm is created by a human, and where there's a human, there is bias, conscious or unconscious bias, and that is how the algorithm gets biased, via the human that creates it. So at the end of the day, as scary as algorithms sometimes sound, and this week with Facebook, you know, in the news and the headline saying Facebook algorithms are destroying democracy, it's not really the algorithms, it's the way that the algorithms are being set up and defined by humans that are posing the threat to bias or other things. It's not the algorithm itself. So the algorithm is nothing to be afraid of. And actually, knowing that humans are involved in algorithms means that we can tackle certain biases and we can actually address and be aware of what those algorithms may be doing and what they may be discriminating against. So let's have a look at an example, because there are two golden rules that we can follow when it comes to making sure that our algorithms are as unbiased as possible. So I've chosen this example. This is the instruction that we're going to give to the algorithm. So we are trying to recruit someone and we are trying to go through a number of CVs, and we're trying to allocate whether or not we would like to interview that person. So the HR manager in this case has given the instruction: if the candidate has at least 15 years experience and a degree in engineering, then put the CV into the interview folder. So that's the instruction. And now the algorithm goes through, ideally, hundreds of CVs and just quickly checks, do they have 15 years of experience and a degree in engineering? If yes to both of those, let's pop them in the interview folder. If no, then they shouldn't be interviewed. That's how that works. So where could there be bias? So I've already said a human defines the parameters that are included in the categorization. In this case, the parameters are at least 15 years experience and a degree in engineering. Those are the two qualifying parameters that this person identified. What's the watch out? The human bit, isn't it? The human can be biased, can be consciously biased, can be unconsciously biased. And if there's a human involved, that bias can go into the algorithm as well. So what I'm not saying is there are humans somewhere consciously writing discriminatory parameters into algorithms. What I'm saying is sometimes we may not be aware of certain things, and as easy as that, you end up with a certain bias. So what's an example for this? If we look at the first bit of the parameter, at least 15 years of experience, let's say at least 15 years of continuous experience, for example, there can be bias in that because women, when they enter the workforce, after a certain amount of time, they may choose to have children. And we know that based on different social parameters and different kind of arrangements and just different social constructs, women tend to be the ones that take time off work, and they may have gaps in their career. So 15 years of experience is quite difficult, can be quite difficult to get. And especially if you say 15 years of continuous experience, for example, that can be difficult to have as a woman. If a man writes this kind of parameter, they may not be aware of that. So that's how a certain bias can creep into these parameters that then choose who should or shouldn't be interviewed. The same goes for things like a degree in engineering, which is a very male-dominated industry. So by saying, oh, they definitely have to have a degree in engineering, they cannot have learned it on a different job or anything like that, I think this definition is already cutting down the number or the gender balance that you will get in terms of applicants, just because of outside factors and certain assumptions that we're making about the qualification of that are required for a certain job. So any bias the human that writes the code has, the code will have as well. And what that means is our first golden rule is we need to have mixed teams of people that work on writing and defining algorithms to make sure that any kind of parameters are being discussed. Are we sure it should be 15 years of experience? Would 10 be okay? What kind of biases may we be implying here that may be ruling out certain candidates that we would love to have in our work mix? And there is actually a little other difficulty with that, because when it comes to information and communication technology, only about 70, so this is from 2017, but back then, only about 17% of those employees are women. So you can see that about 80% of the people that write the code will be men. And that means that you may have a certain bias in a certain direction from the get-go, just because to begin with, there aren't enough females to balance out when it comes to the coding of algorithms. In our team, for example, at Lumina, we actually have a quite female-heavy data team, which kind of puts us in the opposite direction, because we always need to make sure when we write our natural language processing algorithms or when we write our assumptions, that we don't bias that into a female-leaning direction. So that is something that we're very aware of, and the same is the case for any kind of different cultures or different background. So we always want to make sure that we have a mixed team of people that come together and challenge the assumptions that certain algorithms are based on. So let's get to our second golden rule. When it comes to these parameters, at least 15 years experience and a degree in engineering, sometimes we may come up with those from experience, but sometimes we may not know what kind of parameter we should be using. And what we do then is we look at historical data and we have a look at, well, what data is there that we could learn from to understand who we should recruit for this kind of role. But there's something to watch out there as well, because our test data that we are learning from may be biased. So that means we may actually be getting two biased conclusions or biased parameters because the data that we're using to get there is biased to begin with. So I'll give you an example. Most of the data that is being created on the internet these days is being created by men, and that's worldwide, because in lots of countries, the men tend to be the ones that have access to the internet or access to a smartphone, and women don't. And that's why a lot of searches or downloads or uploads or views may be being created by a biased population, because it's mostly men that have access to the internet. So if we use the internet for data, we're going to find really quickly that that data is biased. But on the face of it, we wouldn't know that unless we know how the data is being collected and that it is biased in this way. Another example is medical research. So for years, the male body was being researched much more than the female body, just because there were more male doctors or more male scientists and they were more interested in that field. So you'll have a lot more information about male behavior or the male anatomy than about females. And if you throw that together, the level of detail that you have about the female anatomy or female behavior online will be underrepresented, and it will also not be as balanced and as equal to male behavior. So that data source may be skewed. And the same may be the case if we asked an algorithm, tell us who is better at being a doctor, who should be hired to be a doctor. If you look at the last 100 years of data and look at the share of women or men that were in the medical profession, that data is going to be skewed, because for different reasons that have nothing to do with skill and nothing to do with capabilities, there have been more men in doctor roles than women. And the algorithm doesn't know about social constructs or about barriers to education or about having children. The algorithm doesn't know all of that. The algorithm just looks at the facts, and the algorithm says, well, by the looks of it, men are more suitable to being doctors, and that's why there have been so many over the last 100 years. And that's how we get to biased conclusions and biased premises that we may then code into our algorithms. So any bias the historical data has that we base our assumptions on will be translated into the algorithm as well. And that's our second rule. We need to make sure we know our test data. We need to make sure we know how it's biased, and we need to make sure we balance those biases out in our algorithm, because otherwise we're just going to keep reinforcing that bias through the way that we recruit or the way that we select different things. So you may now be asking, okay, this is all interesting, but where can I come across algorithms in day to day? And sometimes they may be more hidden, and sometimes they may be really, really obvious. So as an example, in HR, we've already used the example of evaluating applicants for roles, but the other one that I mentioned earlier is if you use any social media or something like that, where it's automated, where your job ads are automated and they automate who sees different ads, there may be a bias in the algorithm that they use when they decide who to show your ad to. So it's really important to know whether any partners that you're using in recruitment are actually biased in the assumptions that they're making based on what they think they know about your role. So asking those questions is really important. Demand planning, logistics, buying, anywhere where we use historical data to predict future market demands or future behavior, the same for customer insights. If our historical data is biased in any way and we use that historical data to make assumptions about the future, we need to make sure that we balance those things out. And the same goes for marketing and ad targeting. So again, the job ad, the product ad, all of that could be biased based on historical data or certain assumptions that we're making about who this product is for or who would be using this product. So it's really important to be aware of those things. And so the question now is, okay, well, but what can we actually do? It's three simple things that you can do. And I assume that most of you don't work in an analytics team, but most of you will perhaps work with an algorithm directly or indirectly. So whenever you see some automation or some algorithms or some artificial intelligence, ask about what are the assumptions that were being made when writing this algorithm. Do I agree with the assumptions that were being made? Are they biased in any way? Can I see them? So you should be able to just get a list that, exactly like the example we just looked at, shows you what are the parameters that were being used and what are the actions that are being taken on those parameters. So if you work if you speak to your analytics teams, they will be able to give you a list like that, and you can evaluate for yourself whether or not you agree with them, and then raise that. Secondly, ask them what kind of test data was being used when training the algorithm. Is there any bias in that test data, and did they check for that? And that's actually the third one and most important bit. Bias can be unconscious, and if we don't actively think about bias, and we don't actively think about that our assumptions may be not representative and may be skewed in some way, then asking the question of, are you aware that there may be bias in your assumptions and in your algorithms, is actually the best place to start. Because sometimes you may find that people say, actually, no, I was not aware, I didn't even think of that. And getting that conversation going and moving away from the almighty algorithm that is neutral and not biased and is just so much better at making decisions, getting away from that understanding just will help us in creating better algorithms and fairer algorithms, and will perhaps get us to a point where automated decision making is possible without any kind of bias and without any kind of skew in gender, in race, or any other biases that may be part of those algorithms. So these are three simple things that you can do when it comes to recruiting, when it comes to who you're showing certain ads to just ask those three things. And if you're satisfied that you agree with all of the assumptions, and you're satisfied that the assumptions are being based on good data, then you're good to go. All right. And that's it for me. Thank you.
Marie, thank you so much. I'm just going to step in for Claire because her Wi-Fi has gone down very briefly. So that was pretty mind-blowing, actually. So machines can be unconsciously biased, not just humans. And it's not just the algorithms, it's the people that make them. This is really fascinating stuff. Do we have any questions for Marie? Let's have a look. So here's a big question from Julian Smith. It might be difficult for individuals to influence the companies that use their own data. Rather than wait until we eventually have a balanced gender mix within those businesses that design algorithmic evaluation, have Luminous findings influenced a positive change anywhere in the industry?
Oh, that's a big question, isn't it? So yes, I agree. Maybe I'll take this in bits. So yes, it is very difficult to influence other companies that are using algorithms. I think, if you work with partner companies, it's about raising awareness. And I think, you can't make a partner change. Let's take a social media platform. You can't make them change their algorithm. You can only be aware of it, and you can see whether there's something you can do to counteract it. So perhaps you could ask them whether they can include certain target groups when it comes to recruitment, for example. You could or you could just actively, counter it by recruiting somewhere that is biased in a certain direction, to almost counter the bias in a way. So if you know that there are more women on a certain website or a platform, you can kind of counteract that perhaps. But yeah, I agree, it is very difficult to create change in other platforms. I think the main thing is being aware of it, and therefore trying to work against it actively through different ways. So yeah, it's a difficult one. And then the second part, balanced dinner with it. So I think we don't necessarily have a focus on creating kind of gender balanced algorithms. We use algorithms a lot in our own work when it comes to natural language processing and things like that. So we apply a lot of these principles to our own evaluation because it helps us create better quality data, which is incredibly important when it comes to creating insights. So we want to make sure we provide balanced data, but creating algorithms, I guess we're providing good quality data and therefore indirectly influencing the data that the industry uses, and making sure that it's balanced. and unbiased.
Thanks, Marie. Claire's back with us now. Hello, Claire. A quick question: is this a service that you would actually provide? Because it seems like a lot of companies would benefit from having someone like you on a consultancy basis.
That is probably a question for our sales teams, to be honest. But we're a data company, we are an analytics company, so we're always happy to help when it comes to making sure that data quality is right, and it's something we are really passionate about, and making sure that data is collected in the right way, and that data and codes and things like that are used in the right way. So, get in touch and start the conversation, is I think where we can start.
Thanks, Marie. And there's a couple of recommendations if anyone's watched Coded Bias on Netflix, and a book called Hello by Hannah Fry.